Hey guys, so I'm going to do 2011, and this is number 1, Assembly Language Programming. And essentially what happens is this question is asking, it pretty much made a program that displays what state the state machine is in, with use of a 7 segment, and with use of the state adjuster, which is like, if you press this switch down it becomes 1, if you let it go it becomes 0. Okay. So let me just read the question off for you so you get a understanding of what's going on. So it says, figure 1 below represents a state machine with 2 states, A and B. An HDS12 based system is designed, figure 2, which implements this machine. So the 7 segment of the system displays number 1 if it's in state A, and number 2 if it's in state B. So if it's state A, it's 1, state B, it's 2. It says the following code accomplishes this task, assuming that the input signal of the state diagram is associated with the signal at pin PA3 of port A. So again, this is a switch, and it's attached to PA3 here, if you can see right here. Okay, and it says complete the code by filling in the underlined blank spaces. Okay, so first, I think is a better method to teach you this is just to go through the code and explain why we chose these certain things, and to explain that what it is that we need in order to display these certain things, right? And then afterwards we'll go through it, but just by blanking it out, and I'll post up a follow-up video by just filling it out with you guys, just with only these clues alone. These are the comments that you're given in a test. These are the commands you're given in a test. But here and here, everything that's bolded here is the answer that's filled in. So first, I'm just gonna teach you exactly what it means, and then in my follow-up video, we're gonna do it together, and yeah, and then it'll go back to just the meaning. Okay. So in the first place is that what we need to understand first is that on the 7 segment here, there's port B. Oops, that's not in the video. Okay, so port B is attached to the 7 segment here, right? And so the 7 segment has A here attached to PB6. That means port B pin 6. Okay, and then port B pin 5 is attached to B, and then it goes all the way down by alphabetical order, and then it goes to PB0 and it hits G. Okay, so what's that mean, right? So on a port system, let's say port X has 8 bits. So 8 pins, 4, 5, 6, 7, 8. And these can be controlled by bits. And so essentially what happens is that you can put 1 or 0 inside of each of these positions, of each of these bit positions, and then it'll pretty much tell you if the pin on that port is on or off. Okay, so for port B is attached to the 7 segment, and we're only using pins 0 to 6. We have 8 pins in total, 0, 1, 2, 3, 4, 5, 6, 7. But we're only using 7 pins because there's only 7 segments in the subsegment, right? So, okay, going forward, we're gonna go run through the code now, right? Sorry, and the last thing I need to mention about the ports and pins, port A, for port A, PA3, which is the 4th bit inside of here, which is the 4th bit. If we go back to here, this is, let's say this is 0, 1, 2, 3, 4, 5, 6, 7, right? So for this guy, PA3, which is here, this guy's activated, or it's open or closed for the state machine. It's, like I said in the question, it says when with the signal at pin PA3 of port A, which is the input signal of the state diagram. Okay, so that's the thing that makes the state diagram go to each, whichever one it is, right? So if it's 1, it goes back to A. If it's 0, it goes to B. When it's at B, it goes if it's 0, it goes back to B. If it's A, if it goes to 1, then it goes to A, right? Just like a regular state diagram that we learned before. Okay. So with all the ports and the pins and everything out of the way, we're going to go through the code now, okay? So the first thing we need to know is we need to start off with the variable state, and we need to reserve a memory byte for it of 1, okay? a really good thing to do before this question is to read chapter 2 in full detail, because it'll really help you in terms of all the instructions. Okay, so state reserve memory byte of 1, and why we do that is because we want to have a byte for the memory address state, and so we can put a byte into it and do whatever we want with it, because at the memory address state, there's nothing there. We don't know what it is yet until we reserve a memory byte for it. We can do like a form constant byte or something like that instead of value. But in this case, we don't care what it is, so we're just going to reserve a memory byte for it of 1. Okay. Okay. Now going down the code, we go to SA. That's another label that essentially gives you another memory address, a symbolic memory address of SA. Okay. Remember, it's a memory address. It's not a value. It's a label, and this label has a memory address in it. Okay. So in the memory address of SA, we have the first command is load accumulator A with 0, 0. And this is gonna give us the current state of A. Okay? And this is important, I'll tell you why later. Okay? So 0, 0 for A, the first state A. Okay? And we're gonna store accumulator A into state. Okay? So remember I told you that each of these labels is a memory address. In this memory address state, we're gonna store accumulator A in it, and what's in accumulator A is what we defined in the beginning, which is 0. So we're going to take 0 and we're going to put it in the memory address of state. So state inside of it, it's going to say 0, 0. The contents of the memory address is 0, 0 now. Okay, and then we're going to branch the subroutine display, and display again is another memory address, but the reason why we use labels is because we can see them, or we can put labels on them, like name them, instead of actual numbers like $, whatever the crap. We can actually write letters, type in letters, and we can actually go to the memory address inside of our code, right? So anyways, sorry, I want to make that super clear because it's a memory address. It's very important. It's a very important idea to connect everything together. So when we do branch subroutine display, we go to display here, which is the bottom here. Okay, and so display, what's inside display? So it says load accumulator B with the state. Okay, what was state before? 0, 0, right? Because in here we loaded accumulator A with 0, 0, and then we took 0, 0 and we put it into state. So this is 0, 0 now. Okay, for the first one, 0, 0. Okay, then we're going to load Y with the value of the memory address table. Okay, so that's a memory address. Okay, just keep that in mind. And if you look down at table here, table was defined as table, which is the memory address of table. Okay, and inside that memory address, we're doing a form constant byte, which means we're assigning a value to this memory address. So the contents inside there, inside of table, will have $30 for the first position in table, and then after that, so the memory address of table plus 1 will have $6D. Okay, and I'll explain why that's very important. Okay, and that's important because when we take this value and we load Y with the memory address first, and then we AND it with sorry, hold on. You know what? Before I even get to that, so the reason why we load it up with $30 and $60 is because this represents two states. So this is the 0th position, and this is the first position, right? Let's say table. Okay, so table in the memory, right? Starts here. Okay, and inside of here, content. This is the address, and this is the 0th position. This is the first position from table. Okay, table is just a memory address. Okay, remember it's table is a memory address. So the first position of table, which I've put it here, loading Y, the first position inside of it, inside of the memory address of table, the 0th position has $30, and the first position after table, the memory address of table, the starting position, is $6D. Okay, and why is that important? Is because in here, right? If you look at here, let's say this is port B, right? And port B was connected to the 7 segment of A. Sorry, you can't see that. And port B was attached to the 7 segment here, port B, and it's A is attached to the 6th pin, B is attached to the 5th pin, C is attached to the 4th pin, D is attached to the 3rd, and then keep going until you hit G. So that's what I've written here. So you see here, A is attached to the 6th pin, B is attached to the 5th pin, C is attached to the 4th pin, etc. And why that's important is because 30 in hex, if you look at the hex table, what's 3? 0, 0, 1, 1, right? And what's 0? Obviously a bunch of zeros, right? So why that's important is because if we attach this, if we put these bits inside of port B and we activate each bit, each pin with using these bits in their positions, 30 will look like this, 0, 0, 1, 1, and what's going to be on? This is going to be A, this is going to be B, this is C, and D, E, F, G, right? What's going to be on? These guys, B and C. And what does that look like on the 7 segment? A 1, right? B and C. So if you look in here, just imagine everything else is off and everything that's 1 on the bit addresses. So B and C are on. So everything else is going to be off, and you're going to see a solid B and a solid C. Okay? And so 6D is the same idea. It's taking 6 and D, putting into their binary values, and then attaching those binary values to port B, which is attached to the 7 segment. So let's see, in this case, so A, B, C, D, E, F, G. Right? I alternated between caps and whatever, but it doesn't matter. You understand the idea. So that's what's on this case. A and B are on, D, E, and E are on, and G is on. So what does that make? A 2. So I wrote it here. So A is on, B is on, G is on, E is on, D is on. Okay, so that makes it a 2. So again, look right here. It says state A, it displays a 1. State B, it displays a 2. Okay? And that's why in table, in the memory address of table, for the first position of that address, it's 30, which is state 1, and then, or state A, and then the second, the first, after the first, okay, let's say this is the first address, 0, and the second address, 6D, right? At the second address, they put 6D, which shows off state B, which will display 2, okay? So this essentially is setting, it's almost as saying that, okay, so here's the 2 possible things we can have, and this is our selection here. So if you want the first selection, you just say you want to store the value of table, or the value of the memory, just the first position of just table, into B, and then you want to store that into the port B. Right, and then it'll start showing off on the 7 segment what your state is. Okay, so let me go into more detail. So we'll go line by line again. Okay, so again, just to recap, we had state, reserve memory byte of 1, just have a byte in memory that we can just put. We have a byte in it. We can manipulate it. And we can put whatever we want in it. So the first one we're going to write 0, 0, and that's why do we put 0, 0 is because we want to refer to the first position inside of table, the contents of the first position, which is what? State A, right? Okay, so that's what we do first. So load accumulator A with 0, 0, and we're going to store accumulator A into state. Okay, we're going to store this 0, 0 into state, the memory address of state. Okay, and then we're going to go branch subroutine display, and in display, it's going to load the accumulator B with state. Okay, and then it's going to load accumulator Y with the value. This $sign means value. Okay, the value of table, right? And the value of table means that the memory address. Okay, that means the memory address. So table represents like a memory address. Okay, like your address at home. What's in the contents of that address is you, right? Like you're inside of your home. So the same thing here is the address. The value of the address is just like your house number, okay? So it's the address of the memory inside of the, it's the number of the which memory it's in, the box of memory, it's the label on it, okay? And then it goes add B to Y, okay? Why is this important? It's because if this was state 0, okay, state 0 in the beginning for SA, that means it's gonna go, okay, so it's just gonna 0 plus Y, right? And what's in Y? The value of table. Right? And the value of table plus 0 is still the first position, 0. So $30 is now in Y. That's what $30 is now loaded into B. So load accumulator B with 0 plus Y. This means this 0, whatever, so if it's, let's say let's write it over here. So let's say it was like X dash Y, right? LDAB, right? This means that this position in the memory, let's say this is X, plus this position, and let's say this is Y, right? So this, when you do load accumulator B, it'll load X plus Y. X plus Y. So let's say, even going further into another example, let's say I live at 200 Yonge Street, right? And let's say that's X. Okay, so I say load accumulator B with 200 Yonge Street. Okay, 200 Yonge Street. Let's say it's a house. Okay, and so another one is let's say 2005 Yonge Street. Can't spell Young. Anyways, 2005 Yonge Street. Okay, if I wrote, let's say X equals to this and Y equals to that, right? And LDAB, if I do X comma Y, that actually means load accumulator B with 200 plus 2005 Yonge Street. Okay, so instead of Yonge Street, I want you to think about memory addresses, right? It's represented in a hex, so like $001, right? 0001, right? And I said comma $0003, right? And I said load accumulator B with this guy, comma this guy. What it actually means is load accumulator B with $, with 001 plus 003, 0003, it's 0004. So what it actually means is this guy plus this guy. There's like an offset, okay? But in this case, when I say load accumulator B with 0 and Y, I'm saying that load accumulator B with 0 plus Y, which is just load Y, right? And that's important because Y is what? Y is the value of table because we loaded it before, right? Load Y with hashtag table, right? Which is, or pound table, which is the address of table. Okay? So, and this is important is because, my mistake. It's not actually table. It's and B and Y, right? Add B and Y. So this is this plus this, right? So inside of Y is table, the address of table, plus the address of state. So in the beginning it was, state was 00 plus $. Well, we don't know that it actually is, so we got to say table. Okay, and so table is a memory address as well, similar to $, 0013, like any kind of value, any value, right? So table is like $, whatever crap, right? So 00 plus table. So what does that give us? Just table, right? Inside the memory. And so the reason why they use 0 plus Y is because you have to have an offset in terms of you have to have an offset to determine where do you want exactly in Y, right? Because Y can be any kind of value, right, that we don't know, but it's still an address. So if it's still an address, we have to put 0 in the front, given an offset, and to say, no, just write at that value, please. 0 plus Y, which is just Y, right? And then afterwards, what we loaded into Y, in table, the first position of table is what? What's in table? So let's say this is an address, right? What's the first position? 0 and 1. So this is the first position. At table, an address table, that's the 0th position. That's the first position, okay? And so the first position, like I said before, it was what? 30D, right? Right here. Sorry, 30. And then the second position is what? 6D. Okay? So what's going to happen now? So after I load accumulator B with 0 plus Y, which is the first position, which is with $30, and $30 equals to what? 0011000, right? And what does that create? State A, right? It creates a 1 on the 7 segment, right? This is 0011000, right? And then after it says store that value of whatever you loaded into B, which is what we had was $30, into port B. Okay, and then after it goes into port B, after this goes into port B, what comes out? On the 7 segment, B and C turn on. B and C, right? Which gives us a 1. So say state A. Okay? So now we have all that base figured out. What about, okay, well, what about state B? Okay, so after it goes to state, stores accumulator B into port B, after it takes the table, which was this, but it has this inside, and it takes, which is actually this, and it goes into B, and it has this, right? It returns to the subroutine, which is here, right? So it goes to branch clear, okay? So it goes back to here, and it goes to the next one, okay? So that was for the display only, okay? So now, branch clear. So branch clear, BRCLR, I'm just going to go over it really quickly. The syntax of it is you have your operand, your mask, and then your label or address that you want to jump to. Okay, so what it takes is the operand is actually your test. Your tester, the thing you want to test. Your mask is the conditions you want to set. And then the label is what you want to branch to if these things are true. Or let's just call it a destination. Okay, so branch clear, what happens is, what it does is whatever mask you apply, right? Let's say this guy is 0110. Let's say this guy is okay, let's just say that this guy is what on our hex table. Let's say it's 80. Why not? Yeah, in this case we're going to do 80, okay, or 08. 08. Okay, and so our mask is, let's say, also 08, right? And our label is the next thing we want to jump to. Let's say SB in terms of state B. Okay, and the reason why this is important is because what it does is it takes your, actually, you know what, let's change this into I'll actually just do the actual goddamn question, waste your time. So PTA 08 SB. Okay, so why I chose these things, okay? So PTA, that's port A, right? And port A was shown on here, right? Here, this guy, right? So if this guy is up, the switch is up, it's not pushed, it's 0, right? And so, but what if I say so if it's 0, it goes to B, right? So branch clear, what it does is it asks if the bit at where your mask is, wherever your mask is 1, and it's testing onto something, let's say, in this case, the switch is open, right? So let's say PTA, port A, 1, 2, 3, 4, 5, 6, 7, 8, okay? And this is my mask of 08, which is also 1, 2, 3, 4, and what is 8? 1, 0, 0, 0. So look here, it's our hex table, 8 is 1, 0, 0, 0, okay? So, branch clear. What it takes is it looks at this guy, the bits in port A, and it looks at the mask, and it says, okay, in your mask, whatever you want to test, you set it to 1. Okay? And what it does is an AND operation. So if this guy and this guy is equal to 1, then continue on. But if this guy and this guy is equal to 0, then you're going to branch to whatever SB was, your destination. So it's if mask 1 positions and operand, let's just call it OPR, positions are 0, branch to destination. Okay, so let me just verify that really quick. So if it's doing the PTA, and this is 0, so it starts 1, that's true, so it starts to B. Okay. And the reason why it says clear is because it's testing out wherever you put ones, right? If it's testing, if you put 1 here, then it has to test the second position here, right? Sorry, this is 6th position. So if 1 is 6th position, it tests the 6th position of whatever you're trying to test, and then if it's 0, then if it's clear, then it'll go to the destination. So the only condition that we've set is this guy. In the third 0, 1, 2, 3, in the third position, okay, it has, if for the mask is 1, so in the third position of PTA, it has to be 0 for me to start branching to SB. So that's why we do that. Okay, so since this is 0, right? Let's say this switch is open, then PTA is 0. PA3 is 0. This is PA3. Right? PA3 is 0. So if 1, testing is 0. Okay, good. So it's 0. So now if it's 0, we branch to the destination. We go to B. Okay? So that's what it's doing here. So PTA is the thing being tested. We put the mask, which is 0 and 8, which is 0, 0, 0, 0, 1, 0, 0, 0. Right? And then which is pretty much the PA position. Right? And it's testing if is PA 0 or is it 1. So if it's 0, great. Then we're going to go, and it's BR clear. If it's 0, okay, we're going to go to SB now, which is here. Okay? And we're going to do the same exact process that we did for the state A. Okay? But at this time, we're going to give it another number. Okay? We're going to give it 1. Why? Because later on, when we branch the subroutine state, when we branch the subroutine display, it has to load B with state. It has to load Y with the value of the memory address of table. It's going to add those two memory addresses up, and it's going to load accumulator B with 0 plus Y, right? And in Y, what is that? State plus table, right? And state plus table, in this case, state is 1 now, right? So now it's not the 0th position of table anymore, right? It's the first position after table, which is 6D, right? And then it's going to store 6D, which was in Y, and Y was because of this guy plus this guy, which is 1 plus table, and here's 1 plus table here, is going to go into port B. And then what's going into port B? 6D, right? So 6D, let's see, 6D is written out like this in binary, right? And then I go back into the pins. So the first pin we don't care about. A, B is on, C is off, D and E is on, E, F is off, G is on. So what does that make? A 2. So now this goes into port B, 2. Okay? And then it goes into 2 over here. This goes into 2. Okay? So I hope that was clear. And then it goes to return, after that, after it goes to 2 here, after this goes to 2, it will return to the subroutine. See here on the bottom here, return to subroutine. So after this guy was, after this guy, BR branch subroutine display is done, it returns back to here, and it goes to the next one, and then it says BR set. Okay, and then BR set is very similar to BR clear, except that if this guy is 1 and this guy is 1, then it'll branch. If it's not 1, then it won't branch. That means that if you hold on to this button let's say you let it go. You let the, we're in state B now, so you let the button go, and the button is automatically low, right? And so if this is BR set is 0 and 1 and 0, if BR set is 0, 1 and 0, so I'll read it right here. Okay, we use the exact same thing. Instead, we use BR set instead of BR clear. Okay, and the reason why is because if masks 1 positions and OPR positions are 1, then branch to destination. But in this case, it's not. So 1, the 1 position here, it's testing this guy. This guy is 0, but it's not 1. So it won't branch to the destination. It'll just go to the next line, because it's like an if-then statement, right? So if this is 0 and it's BR set, when this is set, if it's 0, then it's not going to branch. But if it's 1, then it's going to branch. So remember, if it's in the name, clear or set. Set really means 1 and clear means 0, right? So if BR clear, branch of clear, branch of set. If this guy is clear and your command was branch of set and it's not set, it's 0, then it's going to just go to the next line. So in here, branch set 0008, right? It's not let's say it's not set, right? Then we're just going to go down to branch B, SB.